In this lesson, we're going to learn how to use the TI-Nspire Graphing Calculator in order to work with systems of equations. We know we have algebraic methods to solve systems, and we have graphical methods where we can graph and find intersections on paper. But your graphing calculator is an incredibly powerful tool, and today we'll explore some different ways that we can use that. Here's an example. Solve the system using the graphing calculator. Y equals -1/2 x plus 4, and y equals 5/4 x minus 3. We go into our graphing calculator, and we go home, start a new document. And today we're going to add a graph. We have our first equation, y equals -1/2 x plus 4. We hit enter, and the first graph is shown on the screen. Now we want to add a second equation. So we hit the tab key, which is highlighted in red, and notice that brings up the entry screen for a second equation. This time we have the equation 5/4 x minus 3. And again we hit enter. Now we see the two lines graphed on the screen. We also see a bit of a mess where the two equations are printed right near our intersection. It'd be nice to get rid of them, so I take my mouse over to where I see the identifying labels, I click on them to highlight, and then I click on the delete key and it removes the first one. I do that again, click on the label, hit the delete key, and now I have a nice clean graph. Be careful. Make sure you don't click on the line by mistake, because if you do that, it'll actually delete the whole line right off of the graph. Now let's find the intersection. We go to the menu by pressing the menu button, go down to choice 6, which is Analyze Graph, and then choose choice 4, which is Intersection. The calculator will give you a finger and ask you to highlight the region of the graph where the lines intersect. We begin by going to the left of the intersection and either clicking the mouse button or hitting enter, and then slide your finger across the mouse pad to the other side of the intersection, and then again either click the mouse button in the center or hit enter. The point of intersection is displayed on the screen. In this problem, the point of intersection is 4, 2. That's the solution to the system of equations. Now that we're done, we'll go home to clear out our calculator. And now let's take a look at example 2. In our second example, our equations look a little bit different. They are not written in slope-intercept form. We do have two choices. We could solve each one for y and then use the same process that we used before, or we can just work with them as they are. We go in and we start a new document, which is choice 1 on our home screen, and we'll again choose choice 2 to add a graph. To enter the equations as they are, if we hit the delete key to erase the equal sign, notice down at number 6 we have an option called relation. That lets you type equations in exactly as they appear. So we can go 5x plus y equals 1 and hit enter, and it will display the graph of that equation. The disadvantage to this method is that you cannot see an input or an output table. If you try to view that, it's going to tell you that there's an error. The calculator can only find input and output tables for entries that are entered as functions. So if you've changed it to a relation to use this method, you're on your own as far as using tables goes. Now, to enter the second graph, we hit the tab key, which is highlighted in red above the control. We have x plus y equals -3, and again we hit enter. We see that there's a point of intersection. Let's clear the labels out. We move our mouse on top of the first label and click, then hit the delete key. We move our mouse on top of the second label, click on it so it's highlighted, and again hit the delete key. We're now ready to find the point of intersection. Menu, Analyze graph, intersection, and again the calculator shows you the finger. We go on the left side of the intersection, click the button in the center of the mouse or hit enter, slide your finger across the mouse pad until the intersection appears, and then again click the center of the mouse button or hit enter. The intersection is the point 1, -4, and so the solution to the system of equations is 1, -4. Now that we have our answer, we'll go back to the home screen and we're ready to look at our next example. The next example is a little bit different, but very similar to what we just did. What is the value of the y-coordinate of the solution to the system of equations 2x plus y equals 8 and x minus 3y equals -3? We're going to follow the same process. We're going to go into our calculator, start a new document, and again we'll add a graph. Since our equations are not in y equals form, I'll delete the equal sign, go down to choice 6, which is relation, and now I can type in 2x plus y equals 8 and hit enter. And now I can hit the tab key and I can enter my other equation. X minus 3y is equal to -3. My equations are shown on the screen. I'll click on the label so that it's highlighted and hit the delete key. Again, I'll click on the label so it's highlighted and hit the delete key. And now I can find the intersection by going to the menu, choosing Analyze Graph, and choosing Intersection. Calculator gives me the finger, move to the left of the intersection and click or push enter, move the mouse across until the intersection is displayed, and again click or hit enter. The solution is the point 3, 2. Now notice what the problem asks. It says what is the y-coordinate of the solution? The solution is the point 3, 2, and so the y-coordinate is 2, which is choice B. Be careful. Notice that the x-coordinate 3 is also a choice. Don't be fooled by those distractors. Now that we've finished the problem, we go to our calculator and go back to the home screen so that we're ready to start the next problem. In exercise 4, we want to find the value of a in the following system of equations. I'm going to let you try this one on your own, but before we do, there's something important that we have to mention. The calculator does not know the variables a and w. It only knows the variables x and y. So in order to solve this system, you're going to have to rewrite these equations as 2x plus 3y equals 12 and 6x minus 5y equals 8. Please pause the video here, use your calculator to find the point of intersection, and come back when you're ready to check your answer. Let's see how you did. We go into the calculator, start a new document. We add the graphs, and we enter our equations. Delete that equal sign, select relation, and write 2x plus 3y is equal to 12. That gives us our first line. We press the tab key, enter the second equation, 6x minus 5y is equal to 8. I like to delete those equations, so I click on them and then press the delete key. Click on the other one and then press the delete key. We're ready to find the intersection with the menu, Analyze Graph, Intersection, click on the left and drag over the right. The intersection is the point 3, 2. They ask us what is the value of a. Remember, we changed our a to an x and our y, a w, to a y. So the value of a is 3, which is choice 3. While we're here, I want to show you what happens in the calculator if you were to click on a line and then hit the delete key. Notice it erases the line. So if you have a line you want to get rid of, you can always click on it and then hit delete. Now let's go back to the home screen and we're ready to start our next problem. Exercise 5. Which system has the same solution as the system shown below? The system given to us is x plus 3y equals 10 and negative 2x minus 2y equals 4. What we're going to do is basically what we've done several times already. We're going to start a new document and enter each system one at a time and find the point of intersection. Then we'll see which one matches the original. Please pause the video here, take a couple of minutes to use your calculator to find the solution to each system, and then come back when you're ready to compare answers. Let's see how you did. We begin with our first system. We go to our calculator, start a new document. We add a graph, delete that equal sign, select relation, and type in the first equation, x plus 3y equals 10. Press the tab key, enter the second equation, negative 2x minus 2y is equal to 4. We can delete the equations, as we typically do, to get them out of our way. And now we see our intersection up at the top left. Menu, Analyze Graph, Intersection, negative 8, 6. So we have the solution to the original system of equations. Now we need to do the same for each of the others. We enter in the choice A, and we find that the intersection is the point negative 2, 4. We enter choice B, and we find that the solution is negative 8, 6. It looks like we found our answer. We would do the same for each of the other examples. Interestingly, choice D has an intersection that's off the graph, so I want to look at that one momentarily. When we start our document here, and we added our graph, and we changed our input to a relation, we type x plus y is equal to 14. We hit tab and put our second one in, 2x plus 6y is equal to 20. My intersection is off to the right somewhere, but I can't see it. It looks like I need to adjust my window to show a little bit more to the right. I can adjust the window by going to the menu, going to choice 4, which is the window or zoom, and then selecting choice 1, which is the window settings. Notice I have a place to put my minimum and my maximum x value, and down below my lowest and maximum y value. I see my intersection is off to the right. Currently my x-axis only goes up to 10. I can't see what I want, and so I pick a number that's larger. For example, maybe I pick 25. When I do that, notice the x-axis goes much further to the right, and now I see the point of intersection. From there, it's the same as before. Menu, Analyze Graph, Intersection, and then find the coordinates of the intersection. That's how you'll find an intersection when those lines cross off of the screen. But in this case, we wanted to simply find the solution that was identical to the original, which was in choice B. Once again, we'll bring our calculator to the home screen, and we're ready to move on. One final problem for today. The equations 6x plus 5y equals 300 and 3x plus 7y equals 285 represent the money collected from selling gift baskets in a school fundraising event. If x represents the cost for each snack gift basket and y represents the cost for each chocolate gift basket, what is the cost for each chocolate gift basket? Please pause the video here, enter the two equations, find the intersection, and then answer the question. Come back when you're ready to compare your answer. Let's see how you did. I've entered my two equations into the calculator already. Unfortunately, I can't really see anything, so I'm going to have to change my window, and see what happens. I'll go to the menu, I'll go down to my window zoom, and I'll pick my window settings. And I really have no idea where these two equations are. So I think what I'll do is maybe I'll pick some bigger numbers for each my x and my y. Maybe I'll go -50 to 50 and -50 to 50, so for both x and y, and see if I can find my graph. When I do that, I see the intersection up here in the first quadrant. I click on the equations one at a time, highlight them, and delete them. And I use my intersection feature by going to the menu, choosing Analyze Graph, and selecting Intersection. The finger comes up, click on the left, drag over and click on the right. The graphs intersect at the point 25, 30. That's the solution to the system. 25 is x, 30 is my y. And these represent something. The x, according to the problem, represents the cost for a snack gift basket, and the y represents the cost for a chocolate gift basket. Notice in our choices, 25 and 30 are both options. We have to make sure we select the proper one. The question says, what is the cost for a chocolate gift basket? The chocolate gift basket is represented by the y coordinate, which means the price is $30. Again, we go to our home screen, and now we're ready to move on. That's everything you need to know about how to use the TI-Nspire Graphing Calculator to work with systems of equations. It's really a versatile feature, and if you know how to use it, you're at a distinct advantage. You can learn more about systems of equations in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.